A locust is located 25 millimeters from a convex lens with focal length 35 millimeters. Where is the image located? What kind of image is it? And is it right side up or upside down? If the locust is 3 centimeters tall, how tall is the image? We're going to solve this two ways, by drawing a ray tracing diagram and by calculation using the thin lens equation. Let's start off with the ray tracing diagram. As always, we're going to start off by drawing a principal axis. And we also need to set a scale. Your drawing may be to full scale with a ruler. I'm going to use 1 block on the paper is equal to 5 millimeters. And we also need to draw our lens. Just draw it as a thin vertical line. And our focal points. Our focal length is 35 millimeters. And with this scale, that would be 7 blocks. So right here is our focal point on the left, and 1, 2, 3, 4, 5, 6, 7 is the focal point on the right. DO is 25 millimeters from the lens. So our object is 5 blocks, 1, 2, 3, 4, 5, with this scale representing an object 25 millimeters from the lens, and 6 blocks representing something 30 millimeters tall. Now we'll go ahead and draw our principal rays. We'll use blue lines here, and we'll start off with the parallel focus ray. Parallel ray goes through the focal point. The central ray is going to go through the center of the lens without bending. And the focus parallel ray is going to start out oops, I haven't quite gone far enough. We're going to take that ray that goes through the tip of the object and just happens to be coming from the direction of the focal point of the lens on the left. And this is all necessary because our object is inside the focal point of the lens. So that is our focus, and here's the parallel part, like that. So as you can see, the 3 principal rays, even though this is a converging convex lens, are still diverging to the right of the lens. And so what we have to do is figure out where these rays appear to be coming from, because what this is going to be creating is a virtual image. So let me pick a different color here. We'll go with green. And we're going to trace back where these rays appear to be coming from. And we can see here that we're not getting perfect closure. All three rays aren't crossing at exactly the right place, but they're closing at about here. So this is our image, is located right here. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, which is 85 millimeters. So DI is 85 millimeters to the left of the lens. And so another way of saying that is negative 85 millimeters. It is a virtual image because the rays never actually come from this point. They're never actually there. They just look like they come from that direction. And our image is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and a little bit more blocks high. 20 blocks would be 100 millimeters with this scale. Looks to be that the height of the image is about 102 millimeters tall. Now that is our completed ray tracing diagram for this problem. Now let's go ahead and do the same problem using the thin lens equation. One over F equals 1 over DO plus 1 over DI. So 1 over DI is equal to 1 over F minus 1 over DO. F in this problem is 35 millimeters and DO was 25 millimeters. One over 35 minus 1 over 25 gives us that. Negative 0.01143. Now, even though I've rounded that a little bit here for the purposes of writing it, I strongly recommend that you just take the full precision number in the calculator and just invert that, and we get 87.5 millimeters. So DI is equal to 87.5 millimeters, and let's go ahead and round that to 88 millimeters. And actually, that would be negative 88 millimeters because of the minus sign here. We had negative 85 millimeters from our drawing, so very good agreement. The magnification is negative DI over DO, gives us negative of negative 88 over DO, which was 25. 88 divided by 25 is going to give us 3.5. So the image is 3.5 times larger than the object. So the height of the image is going to be the magnification times the height of the object. So 3.5 times the height of the object, which is 30 millimeters. And that's going to give us 105 millimeters as the height, the calculated height of our object. Now what did we get in our drawing? We said 102 millimeters. The calculation says 105 millimeters. Pretty good agreement.